Now let us see how retrieval augmented generation or RAG pattern is implemented in real world. The steps to implement RAG as we saw are pretty straightforward. First, we retrieve or gather relevant data based on user query. Say for example from a database or from large set of documents using similarity search or searching various other sources like World Wide Web. Number 2, we augment the prompt and create an updated prompt by concatenating or reworking and reformatting the information gathered in step 1. And finally, we send this newly created prompt to the LLM to generate a better response. Let us dive deep and look at it in detail. Remember, we saw that we have three layers for any GenAI system? For prompt engineering, we collapse these into a single layer for simplicity. Now, for RAG, we will have to again unfold these layers as RAG is implemented at the application layer level. So, for RAG discussion, we will consider the application layer and the LLM layer. We need not worry about the front end layer as we will assume the front end layer will do its job and send us properly formatted user prompt. We saw that LLM is already trained on vast amount of varied data, but it is all generic data, and hence we need RAG to augment this training by specific data sent via the prompt. Let us see how. So the application layer gets the user prompt. At step 1 in RAG, using this prompt, application layer retrieves the relevant information from various sources. For example, as we saw, if the user query is about leaves, we retrieve the HR policy related to leaves. Then step 2, we augment the prompt with this gathered information. And then we send it to the LLM to generate a personalized output. The critical step 1 and step 2 of RAG pattern are executed by the application layer. Let us look at the detailed example now. Suppose the use case is to create IT support ticket resolution using RAG pattern, where user can submit a query, example, why is my laptop overheating after software update? And GenAI system will utilize RAG pattern to provide accurate resolution steps. To implement this, first the retrieval. Let us assume there is a support knowledge base which is always kept up to date. For example, a .xls file or a database. Generally, application layer uses code like Python code to do a SQL query on this support database to retrieve the most relevant resolution steps for the user query. Application layer will use the user query as the search criteria while doing this SQL search. Step 2 is augmentation. Here in the same Python code, application layer will augment the user query with retrieved information and create an enriched prompt. And finally, the Python code would send this prompt to the LLM like GPT or Gemini using LLM APIs. This is a little different than how we access the LLM in prompt engineering section. Now we are accessing the LLM programmatically through our Python code. This is how real world applications are built. We will see this example built in the practical lecture at the end using Python code and LLM API. Diagrammatically, this will look something like below. First, the user prompt is sent to the application layer. For example, here the user prompt is user query asking for the reason for laptop overheating after software update. Application layer accesses the knowledge base with SQL search in this case with the word heat and gets back the possible resolution from the knowledge base. It then updates the prompt with this information and asks the LLM to provide detailed steps using this updated information. The LLM then uses its generic training as well as this updated prompt to work out the steps and comes with a more pointed resolution. Thus, we saw how RAG is implemented at the application layer using database query in this case. Next, we will see more options that the application layer has to retrieve relevant data, particularly using similarity search.